chlorine has 7 valence electrons. And that just means 7 electrons in its outermost energy level. So now let's talk about how ions form. Remember, atoms have a neutral charge, but ions have either a positive or negative charge. So if we look at sodium, now we're just going to draw the sodium, just the electrons for the sodium atom. Okay? We're only going to draw the valence electrons. So remember, in sodium, our third energy level had 1 valence electron. And for chlorine, which is going to be called the chloride ion, in its third energy level, it had 7 valence electrons. So ask yourself, what does chlorine need in order to be stable? An atom is stable, or an atom is stable when its valence shell is filled. And we know that the valence shell is filled with 8 electrons. So if chlorine were to gain 1 electron, then it would be stable. Gaining 1 electron would make chlorine stable, and it would be called a chloride ion. Sodium, if sodium were to lose this electron, then if you remember, the second energy level already had 8 electrons in it. So the second energy level would be filled if we removed the 1 electron from the third energy level. So if sodium loses 1 electron, it will be stable. It will have, both of these will have a filled valence shell, or filled outer energy level, filled with 8 electrons. So it's kind of, I guess you could say a coincidence, I don't know, but sodium has 1 electron to lose, and chloride, or chlorine, needs to gain an electron. So they can basically help each other out. Sodium will lose an electron, and it will become a sodium ion with a positive charge, because think about it, if it's losing a negative charge, then it will have an overall positive charge, because sodium had 11 positive charges, 11 protons, and then it had 11 electrons. Well, if you change that 11 to 10, now you've got an extra positive charge, and that gives sodium a positive charge. So this is called a sodium ion instead of atom, because the ion has a charge. And then here, since chlorine is gaining an electron, it's going to go from having 17 protons and 17 electrons to having 18 electrons. That will give it 1 more negative charge. So we call this now the chloride ion. And because they are opposites, because opposite charges attract, the sodium and the chloride ion will be attracted to each other, and they will form what is called an ionic bond. So an ionic bond is formed from oppositely charged ions.
Oppositely charged ions
attract.
Are attracted to each other.
An example of an ionic bond, it's probably the most common example in science, is sodium chloride. Okay, it's called sodium chloride, which we know as salt or table salt. But actually, anytime you have a positive ion and a negative ion forming an ionic bond, unless the positive ion is hydrogen and the negative ion is hydroxide, then the compound is a salt. It's a type of salt. So if it has hydrogen or hydroxide in it, it's not a salt. But if it has hydrogen, which is hydrogen with a positive charge, or hydroxide, which is oxygen and hydrogen together as a group with a negative charge, then then it is a salt. So it doesn't have to be sodium chloride. It can be, I don't know, magnesium bromide, which has a different ratio. There's 2 bromide ions for every magnesium. But the point is, or calcium chloride is another one, calcium chloride. Another common one is potassium chloride. So any of those where you have a positively charged ion and a negatively charged ion that are attracted because they're opposite charges, then that is a salt. Okay? So it's not just NaCl that's salt, it's also there are also other salts in chemistry. Now, the ionic bond is one way that atoms can be attracted to each other and form a compound or molecule. Another bond is called the covalent bond. So let's look at carbon. The carbon atom, the symbol on the periodic table is, the atomic number is 6, and the mass number is 12. So when we draw carbon, we're going to have, in the nucleus, we're going to have 6 protons,